Hi, what is the value of k? Given that we have k to the power of 6 equals 1. Then let's find all the possible solutions. We know we have k to the power of 6 equals, we can have 1. When we have 1 to the power of 6, it's same thing as 1. So we can replace this as 1 to the power of 6. Let's express this power as k to the power of 3, all in parentheses to the power of 2, then equals 1 to the power of 3, all in parentheses to the power of 2. So we believe that 3 times 2 will give us 6. So let's take this right hand side to this side, then we will have k to the power of 3, all in parentheses to the power of 2, minus 1 to the power of 3, all in parentheses to the power of 2, then we set everything to be equal to 0. Then we are looking at this expression. This one has power 2, this one has power 2. It's difference of 2 square, and which says that when you have a to the power of 2 minus b to the power of 2 equals as, open the parenthesis, a plus b, all in bracket, multiplied by a minus b, all in bracket. This tells you that our a equals k to the power of 3 and our b equals 1 to the power of 3. So therefore we are going to have here to be k to the power of 3 plus 1 to the power of 3, all in parentheses, again multiplied by k to the power of 3 minus 1 to the power of 3, all in parentheses, then everything equals 0. Now for this particular expression to be equal to 0, what we are saying is that, let's say case 1, is that k to the power of 3 plus 1 to the power of 3 must be equal to 0, or we have case 2. K to the power of 3 minus 1 to the power of 3 must be equal to 0, for this expression to be equal to 0. Then let us all recall that when you have sum of the two cube, when you have a to the power of 3 plus b to the power of 3, this always equals as, when you have open bracket a plus b, you close the bracket, again multiply by a square minus ab plus b square. So applying it here, we are dealing with case 1. So we are going to have k plus 1, all in parentheses, multiplied by k square minus, here will be minus k, a is k, b is 1, plus b is 1 to the power of 2 will be 1. Then we set everything to be equal to 0 from here. Then it is obvious that from here, it's either we have k plus 1 equals 0, or we have k square minus k plus 1 to be equal to 0. And so from here we have k to be equals minus 1 as the first obvious real solution. From here we can also get the possible value of k, where we have k to be equals, using the quadratic formula, will be minus b, positive or negative, square root of b square minus 4ac divided by 2a, where we are going to have a, the parameter a is the coefficient of k square, which is 1, so our a equals 1. B is the coefficient of k, which is minus 1, so our b will be equals minus 1. While c is the constant, which is equals 1. When you plug in everything here, then we are going to have k to be equals, here is already minus here will be 1, positive or negative, square root of, here will also be 1 minus 4 times a is 1, c is also 1, so divided by 2 times 1 will be 2. Here will be 1, positive or negative. Now looking at this expression, we can see that we are going to have square root of 1 minus 3 will be equals 1 minus 4 will be equals minus 3. Then all divided by 2. So we are going to have k to be equals 1 positive or negative, we can re-express this as 3 multiplied by root of -1, then all divided by 2. And this will be equals as 1 positive or negative root 3. But remember that when you have root of -1 equals I in a complex space, so here will now be 1 positive or negative root 3I divided by 2. That is the first complex solution for case 1. So for case 1 we have this. Then let's go with case 2, where we have k to the power of 3 minus 1 to the power of 3 to be equal 0. And remember that when you have a to the power of 3 minus b to the power of 3, this also equals as when you have open bracket a minus b, you close the bracket, again multiply by a to the power of 2 plus ab plus b squared, you close it. So by applying it here, we can see that our a equals k, while our b equals 1. So we are going to have here to be equals, applying this one, k minus 1, all in parentheses, again multiplied by k squared, plus a is k multiplied by b is 1. We have here to be plus k plus 1. 1 squared will be 1. Then we set everything to be equal 0. Now from here also, is either we have k minus 1 to be equals 0, or we have k squared plus k plus 1 to be equal 0. For this expression to be equal 0, and which is obvious as well that from here we are going to have k to be equals 1. Another obvious second real solution. From here also we can get the possible value of k by using quadratic formula to be equals k equals minus b, positive or negative, square root of b squared minus 4ac, then all divided by 2a. It is obvious that the parameter a from here is the coefficient of k squared 1. Parameter b is the coefficient of k 1, while the parameter c is the constant 1, which is equals 1. So when you put everything here, we are going to have our k to be equals, here is b equals 1 is minus 1, positive or negative. 1 squared will be 1 minus 4 times a is 1, c is also 1, so here will be 4, then divided by 2. So this will give you minus 1, positive or negative, root of 1 minus 4 will be minus 3 divided by 2. Then we have k to be equals minus 1, positive or negative, root of 3, again multiplied by root of minus 1, all divided by 2. So we can have this as k will be equals minus 1, positive or negative, root of 3 I divided by 2, root of minus 1 equals I. So finally, for case 2, we also have k to be equals 1, and we also have k to be equals minus 1, positive or negative, root 3i divided by 2. While for case 1, we have k to be equals minus 1. Then we also have k to be equals 1, positive or negative, root 3i divided by 2. Now, you can see we have how many solutions? We have 6 solutions. Why? Because we have the problem to be power 6, k to the power of 6 equals 1. And that is why you cannot decide that you want to look for the only real solution, because it's not specified in the given problem. So if you are new here and find this video interesting, don't forget to share, like, comment, and subscribe to my YouTube channel for more math tutorial videos. Bye bye.